Before VLANs existed, networks were simple. You plug devices into switches, the switches forwarded traffic, and most of the time everything worked. And that's important to say out loud. Nothing looked broken at first. As long as the network was small. A few PCs, a few printers, maybe a server or two, you didn't feel any problems. But as networks grew, more people, more devices, more background traffic, something subtle started to fail. It wasn't hardware, it wasn't cables, it wasn't link speed, and it wasn't switch performance. It was structure. The network stopped being easy to reason about. And VLANs exist because of that exact moment. This video is not about memorizing what a VLAN is, it's about understanding why VLANs became unavoidable. Because once you understand that, every VLAN topic later will feel obvious. Let's look at what networks looked like before VLANs. You might have one switch, or several switches connected together, but logically, it's still one network, one local area network, one broadcast domain. Everyone belongs to the same group, everyone hears the same things, and again, this is important, switches are already doing their job correctly. There are no collisions, no shared media, and there is fast forwarding. So nothing screams problem yet. Which is why flat networks are dangerous. They fail quietly. Even when users aren't clicking anything, the network is never idle. Devices are constantly asking, who has this IP, announcing services, discovering neighbors, sending background traffic. Most of this traffic is broadcast traffic, and here's the key reminder. Broadcast traffic goes to everyone. Every single device must receive the frame, process it, decide if it matters. Most of the time it does not. One device doing this is nothing. But now imagine you have 50 devices, 200 devices, or even 1,000 devices, all talking, all interrupting each other. That's not dramatic failure, that's constant low-level inefficiency. At this point, a very natural thought appears. Switches are smart. Why can't they just stop this? And the answer is, they can't, by design. Switches operate at layer 2, and at layer 2, broadcasts are supposed to reach everyone. There is no idea of separate networks yet. So when a switch receives a broadcast frame, it must forward it. This means you get perfect collision handling, fast forwarding, but still one huge broadcast domain. Switches solved interference, but they did not solve broadcast scale. And that's the wall flat networks hit. So let's say the problem clearly. The problem is not speed, the problem is not switching technology, the problem is that broadcast domains became too large. And the old solution, physical separation, is very painful. Because physical separation means new switches, new cables, and new layouts. Every time a department changes, people move or teams grow. The network needed a way to stay physically the same, but behave differently. That design pressure is what created VLANs. Now we're ready to define VLANs. A VLAN is a logical separation inside a switched network. Logical is the important word. Nothing physical changes, but behavior changes. A VLAN creates a separate broadcast domain. Same switch, same cables, same ports, but different who hears who. A VLAN is not a thing you plug in. It's a rule about who belongs together. Let's slow this down. Physical separation means this switch is for accounting, that switch is for engineering, and cables define identity. Logical separation is VLANs. The same switch serves everyone, but behavior depends on VLAN membership. Why does that matter? Because people move, teams reorganize, offices change. VLANs let the network follow organization, not the furniture. This is the hardest concept for beginners. Without VLANs, one switch equals one network. With VLANs, one switch equals multiple invisible networks. Each VLAN behaves like its own local area network, its own broadcast domain, and its own isolated environment, even though the cables are shared. This is where you stop thinking physically. The switch is no longer one network. It's many logical networks sharing hardware. Let's return to the original problem, broadcast. Broadcasts are necessary, but they must be contained. VLANs do exactly that. A broadcast inside VLAN 10 stays in VLAN 10. It never reaches VLAN 20, and it never interrupts VLAN 30. That containment is the entire reason VLANs exist. Everything else builds on this. Think about departments. Without VLANs, accounting hears engineering noise. HR hears IT diagnostics. Everyone hears everything. But with VLANs, accounting is in its own broadcast world, engineering is in its own broadcast world, HR and IT are isolated. Same building, same switches, same cables, but different logical structure. Now think in terms of floors. Each floor gets a VLAN. Here's the important shift. Network identity is no longer tied to where the cable is. Someone can move desks, change floors, change rooms, and still belong to the same VLAN. VLANs separate location from network membership. This slide saves beginners a lot of pain. VLANs do not route traffic. They do not connect VLANs together. In fact, VLANs are designed to isolate. If two devices are in a different VLAN, they cannot communicate with each other, even if they're on the same switch, even if they're right next to each other. That isolation is the whole point. A VLAN is not equal to subnet. This confusion is everywhere. VLANs are layer 2. They control broadcast domains. Subnets are layer 3, and they control IP logic and routing. They often align, but they are not the same. Structure first, IP logic later. Routers break broadcast domains. So why not just use routers? Because routers cost more, they add complexity, and they don't scale inside LANs. VLANs give you structure without turning the LAN into a routing maze. Think of a switch as a building. Without VLANs, one open hall, one loudspeaker, and everyone hears everything. But with VLANs, same building, internal walls, separate rooms, and separate loudspeakers. Nothing physical changes, but behavior does. Let's lock this in. VLANs matter because they contain broadcast traffic, create logical structure, allow networks to scale. Without VLANs, networks stay flat, noise spreads, and growth hurts. But with VLANs, structure emerges, behavior becomes predictable, and networking starts to make sense. VLANs aren't optional, they are foundational.